Okay, now let's talk about what happens when you have more than one factor. And in this lecture, we're going to focus on having two factors, and that would be called a two-way ANOVA. All right, and we're going to go through this with and without interaction. So interaction would be these two factors interacting with one another. All right, why do we need a two-way ANOVA? All right, so far we've only considered variation between factor levels and within factor levels. So between the factor levels, all right, that is our eta squared, and then within the factor levels would be our error. But other sources of variation can exist. We know this because we have error. And so sometimes we want to try to explain more of the variation we see in our dependent variable. And so we'll do this by adding another meaningful factor to, in fact, reduce the error. Reducing the error, reducing the error reduces the denominator of the F statistic, which actually makes it more likely to reject the null hypothesis. All right, so the bigger the error, the bigger that of unexplained variance, the less likely we are to reject the null. But if we're adding factors, we're explaining more and more of the error. So that's going down, which makes it more likely to reject the null. All right, so blocking variable. This second factor added to an analysis is often called a blocking variable, but I'll be honest with you, most of the time people just refer to it as a second factor. All right, so let's work through this example throughout the lecture. A random sample of 40 people are put into one of four groups. They are either put on diet 1 or diet 2, and they are either put into an exercise group or a sedentary group. Does mean weight loss significantly vary by diet or exercise? All right, so we've got two factors here. We've got the diet factor, and then we have the exercise or sedentary factor. All right, so here we have four samples, which makes this an ANOVA. And we have two factors, the diet and exercise, which makes this a two-way ANOVA. All right, note in this example, we have one weight for each diet and exercise group, okay? All right, writing the hypotheses. All right, so I told you after that we were done with the two sample hypothesis testing, when we got to the one-way ANOVA, I told you hypothesis testing was getting simpler in terms of writing them. It's going to stay kind of simple. It's just really repeating what we did in the last lecture with one-way ANOVAs. All right, the only difference is now that we have two factors, we have two hypothesis tests. All right, so in this example, again, we've got the diet factor and we have the exercise factor. All right, so for diet, we have a null that all diet means are equal, but really we only have two, so we could say mu diet 1 equals mu diet 2. And an alternative, at least one diet mean unequal, but again, because there are only two, we could simply list the means and say mu of diet 1 is not equal to mu of diet 2. And then we also have our exercise factor. So here our null that all exercise means are equal, but again, we only have two means. We have the mu exercise group equal to the mu non-exercise group, and an alternative of at least one exercise mean unequal. All right, but again, with only two means, we could say mu exercise is not equal to mu non-exercise. All right, so there will be two p-values, two decisions, and two conclusions. All right, so in our ANOVA table, once we get over to JASP, there will be a diet factor with a p-value. There will be an exercise factor with a p-value. And since we have two p-values, we'll have two statistical decisions and two conclusions. All right, so now let's talk about interaction. What is interaction? All right. In the previous example, we would determine if mean weight loss between diets averaged over both exercise groups is different. All right. In other words, is diet a significant factor in weight loss? All right, we would also determine if mean weight loss between exercise groups averaged over both diets is different. So again, does weight loss vary significantly across exercise and non-exercise? Does exercise significantly contribute to weight loss? All right, so what could explain these differences? Type of diet, amount of exercise, right? So you've got the diets vary, so the type of diet could explain the difference. All right, we've got exercise versus non-exercise, so the amount of exercise could explain differences. All right, but what about the interaction between diet and exercise? Meaning the differences depend on both the diet and the exercise. Meaning, do you lose more weight in the exercise group on diet 2 as opposed to diet 1? All right. There's a data requirement that we have to test for interaction. All right. Replication of data must be present. All right. What do I mean by that? I mean that we have to have a sample for each factor by factor crossing. So for each diet and each exercise group, we must have multiple people contributing to the weight numbers. Okay? In other words, for each factor by factor crossing, there must be multiple observations. All right? For you, the student, your hint will be that I'm asking you about interaction, right? If interaction doesn't really apply to the problem, then as the teacher, I'm simply not going to ask about it. All right? But when it comes to your project, you need to know when you can or cannot ask for interaction. If you try to test for interaction in JASP when you do not have replication, JASP simply will not give you a p-value for the interaction. But I'm going to show you how you can turn it off. All right, is interaction present? All right, so you notice here, and this is just a make-believe graph or an interaction plot that I'm giving you. And we have with exercise is the orange line and without exercise is the purple line. And we're looking at weight loss across the two diets. Notice that the lines are not parallel, right? We see that the orange line has a greater slope than the purple line, all right? And what this means, all right, when our lines are separated by exercise here, we would say exercise is a moderator. Exercise is moderating the relationship between the diets. That really is just fancy talk for the fact that exercise and diet do interact, all right, and that you can lose more weight on diet 2 with exercise, right? So diet 2, it appears, looking at both lines, that you lose more weight on diet 2 than diet 1, all right? But because of the greater slope on the orange line, what we're seeing there is that you lose even more weight on diet 2 with exercise. All right, so step 1 here is doing an interaction plot. All right, if the lines are parallel, there is likely no interaction. And if the lines are skewed or crossing, there is likely potential interaction. And again, this plot is just showing us potential interaction. All right, we cannot say it's significant until we actually see a p-value for that interaction. In research, let's say that in your final project for the semester or in your dissertation, you are running an ANOVA and you're testing this interaction maybe between race and sex, would be an example, and it turns out you have a significant interaction. Then in your thesis or dissertation or in your final project this semester, you would want to include an interaction plot to actually show what that interaction looks like, okay? All right, writing the hypotheses to include interaction. So now if we're testing interaction also, what is that going to look like? Well, now there are 3 hypothesis tests. We have the diet factor that we've already discussed. We have the exercise factor that we've already discussed. And now we have to test interaction. So we've got a hypothesis test for interaction. So what is that going to look like? The null would be there is no interaction between diet and exercise. And the alternative would be there is significant interaction between diet and exercise. All right, so now this gets to be a lot to type or write. We've got 3 p-values, we've got 3 tests, 3 p-values, 3 decisions, and 3 conclusions. All right, but you'll see that whether it's the homework or the quiz, I tend to step you through these. All right, at this point, you should be ready to do the two-way ANOVA classwork.